Welcome back. My name is Anand and you're watching Young Physicist. In your daily life, when you look the world around you, you observe that an object which is present at a position cannot be present somewhere else at the same instant of time. But this can happen at the microscopic level. According to the laws of quantum mechanics, if a particle is present at a position, there is finite probability that the particle can also be present at some other position at the same instant of time. Good news for all of you, right? You can attend your important physics class at the same time. You can be present at the shopping mall with your friend. Strange, right? That's how the nature behaves at the microscopic level. This is the fundamental reality of the nature at the microscopic level. If you want to study the motion or dynamics of any particle, you need to know where the particle is and where the particle is going at some instant of time. There is a very interesting principle in quantum mechanics known as Heisenberg's Uncertainty Principle. This principle says it's impossible, it's completely impossible to measure the position and the momentum of any microscopic particle simultaneously with absolute accuracy. Let me elaborate this. If you are able to measure the position of any microscopic particle with a great accuracy, there will be big error, there will be big uncertainty in its momentum. And if you are able to measure the momentum of any microscopic particle with great accuracy, there will be uncertainty in the measurement of its position. Why? If you want to determine the position of any particle, you should be able to see the particle. To do so, you can illuminate the particle with a light of certain frequency or certain wavelength. When you send the light of certain frequency or certain wavelength towards the particle, the light will hit the particle and it will give you the information about the position of the particle. In this process, the photons of light will hit the particle and will change the momentum of the particle. At the instant you measure the position of the particle, the momentum of particle was different. Now the collision between the photon and the particle has changed the momentum of the particle. Now the act of measurement of the position of the particle has brought uncertainty or error in the momentum of the particle. Now if we want not to change the momentum of the particle, we can select the light or we can select the photon in such a way that the momentum of photon should be very less as compared to the momentum of the microscopic particle. For a photon, the momentum of the photon depends upon the frequency of the light. So to have a photon of lesser momentum, we should use the light of lesser frequency. If we use the light of lesser frequency, we will not be able to measure the position of the particle, because the laws of optics says if you want to measure the position of the particle, you should use the light of larger frequency. So in this process, you will be able to measure the momentum of the particle, but the position of the particle will not be measured, because the device we are using should have high resolution, and high resolution of the device is possible only when we use the light of larger frequency. It doesn't mean that we don't have advanced or sophisticated technology to measure the position and the momentum of any microscopic particle simultaneously with absolute accuracy. This is the fundamental limitation of the nature. The nature doesn't want us to measure both these two quantities simultaneously with absolute accuracy. If you have further any doubt, you can tell me in the comment section. If you like this video, please like and share the video, and don't forget to subscribe the channel young physicist. Thank you very much.